All right, last equation we're going to sketch is maybe the most complicated, but we'll do it the same way as we did the previous one. So this is the other one that we solved, t times y prime plus 2y equals 4t squared. Let's just get y prime by itself to make this easier. So subtract 2y from both sides and divide both sides by t. Here's what we get. And then we'll note this t greater than 0 domain thing that we had to guarantee existence and uniqueness. We'll talk about that a little bit as well here. Okay, so let's use the same technique. Well, before we even do that, let's observe that y prime does not exist when t equals 0. Okay, so that might be funny. Previously, actually, we sketched vertical slopes there. That does not quite apply here, because that would be the equation t equals 0. If there's all vertical slopes when t equals 0. Let's just check that. Sub t equals 0. Then we get 0 times y prime plus 2y equals 0. So y equals 0. Okay, so maybe we could argue that the point 0, 0 is on one of the solution curves, but the curve t equals 0 is certainly not a solution curve. Okay, so we cannot sketch vertical slopes here. That was specific to the other problem that we've previously done this in. Okay, so we can still ask, when does y prime equal 0? Then we'll have 0 equals 4t minus 2y over t. So 2y equals 4t squared, and y equals 2t squared. Okay, so we get a nice parabola. Let's put in some numbers here. 0, 1, 2, 1. Okay, so it'll go through, this is a stretched parabola, so at t equals 1, we're actually going to go through 2. Same thing for negative 1. Okay, pretty stretched out parabola. And then remember, this is, on this parabola, all the slopes are 0. So I draw horizontal lines there. I can make them as dense as I want, but if I zoomed in, there'd be a horizontal line everywhere. Okay, and remember, this green thing is not a solution curve. Try to keep that to blue, at least for these recent videos. Okay, what else? Well, I can plug in some points. So let's say, what don't I know? Like maybe 1, 0? At 1, 0, y prime is, let's see, 1 times 4 minus 0 is 4. Okay, so pretty steep slope. And then at negative 1, 0, it should be pretty similar. Y prime should be negative 4. And if that's negative, the other thing's still 0. Okay, pretty steep there. Okay, what about, I'm curious about, this is 1, 2. What about 1, 3? Y prime is 4 minus 6, right? It's negative 2. Okay, that slope there is negative 2. Not quite as steep as the 4. And then I can check, same thing, negative 1, 3. I'm going to evaluate that. That actually is going to come out to negative 4 plus 6 is going to be positive 2. Okay, positive 2 there. Okay, I could keep doing this forever, but maybe that's going to take too much time. Okay, so let's generalize. What about y prime greater than 0? Let's actually look at that. This thing is greater than 0. 4t minus 2y over t is greater than 0. So 4t is greater than 2y over t. I would like to multiply both sides by t, but actually the sign of t is going to change what happens? So either t is greater than 0, and we have 4t squared is greater than 2y, meaning y is less than 2t squared, or t is less than 0, this sign flips, and 4t squared is less than 2y. So y is going to be greater than 2t squared. Interesting. Okay, what does that mean? Let's look on the graph. I had an orange pen. There it is. Okay, it's going to shade in orange. Okay, so t is greater than 0 is everything over here. Y is less than 2t squared is everything under the parabola. So here, this is where slopes are positive. And then t is less than 0 is everything over here. Y is greater than 2t squared is everything higher than the parabola. So here, up until the y-axis, everything shaded in orange is where slopes are positive. Everything else, and we could solve this separately, is where slopes are negative. I could solve a y prime is less than 0. I would get everything else. It would be cases like this. Okay, that's pretty interesting. Still don't have a lot of lines here. Still don't know where the solution curves are, so we'll just cheat because we've already solved this. And you go on, again, Wolfram Alpha or your TI-80 something or Desmos or your other favorite graphing technology. Maybe you've programmed one in Python yourself. I don't know. Okay, so these are the solution curves. And you can start putting in values. I would just go ahead and put in values for a minus 1. I think that this actually originally was c, so that's why. Okay, so first of all, for a equals 1, you're going to get y equals t squared. I do know how to graph that. That is the not so steep parabola. And it is going to go through this 0 thing. Let's see, 1 comma 4. Maybe we'll get this right. Okay. That parabola. Cool. So that's one solution curve. And then if you put in positive values of a, so you're adding things to this parabola, what ends up happening, as t gets close to 0, or sorry, positive values of c, which means a greater than 1, as t gets close to 0, you're going to get y goes to infinity. This will go to 0. We have positive number over very small positive number, because t is squared. Y is going to go to infinity. It doesn't matter which side t goes from. So what this actually looks like is we're going to have a curve like this. It's going to stay inside this parabola that we drew, this one solution curve. So they're going to have minima on this green parabola. And then you're just going to get a bunch of things like this. They're, each graph is two little, they're not parabolas anymore, two little curves. So by the way, let's actually talk about this t greater than 0 thing. So what happens, if you start somewhere, you're at an initial value, and you're now stuck on the solution curve, right? You graph out the solution curve, as long as the thing is continuous. But here, because none of these cross t equals 0, so if I wanted to cross, I could jump to a different solution curve. So that's where we lose uniqueness here, if you don't restrict to t greater than 0. If you restrict to t greater than 0, then we're stuck on one solution curve. If not, then cross the t equals 0 line and anything goes. I could jump to a different one. My slope field does not force me to stay on the same one. But if I graph this in Wolfram Alpha or whatever I want, I get these two symmetrical things. So differential equation is not true to the analytic solution curves that I solve for in the whole domain of real numbers. Okay. If I have a equals 1, then as t goes to 0, y goes to 0. That was this blue parabola that I drew. And then if a sorry, not y. If a is less than 1, then as t goes to 0, let's think about this. This is a negative number now. This goes to 0. Negative number over t squared is still some small positive number. Then y is going to go to negative infinity. And the graphs of these look kind of funny. If I graph this, I get like a crazy bowl thing. Sorry. They have 2 parts as well, but because of this black hole basically at t equals 0, if I don't restrict my domain, I could come over here and I could jump to anything. Actually, in fact, I could come over here and I could jump to a curve up here. My slope field does not preclude that because I'm going off to negative infinity. I never pass t equals 0. I can do whatever I want once I'm past it. Okay, so there's the sketch of that. You do not have to be able to sketch these by hand. Obviously, I didn't sketch these parts by hand. I looked them up. So that's fine. This is just to visually see what's happening with this differential equation that we solved.